Special speakers today. We also have a new person, Ruslan Topau, over there, is starting on Monday, but he's coming over here and drinking our wine today. And we're pleased to have speakers representing Biomimicry today. Chris Allen, whose office is right here in 3030 Bridgeway, right in Sausalito. And Mike Flaxman, who is a collaborator. And biomimicry is basically translating biological forms into design, whether it's product design, architectural design, landscape design. And Justin and I had the pleasure of meeting Chris at the ULI Resilient Cities conference recently. I think you were there too, Jason. And some other people were manning the desk. We had a display. And the subject is just so interesting and kind of relevant to us as landscape architects. And Michael, in fact, is a landscape architect from GSD and was a protege of Carl Steinitz, and then worked for ESRI, and then taught it at MIT in planning, and is now out here in San Francisco. So they're going to give us a brief presentation, and then we can think about ways to collaborate or ways that biomimicry kind of feeds into our design work as landscape architects. And with that, everybody have a drink. And thanks to Hua Young and Yao, his girlfriend, for bringing some special treats today. So come on and sit down so that people can come in and.
You do too, Wenwen. You've got my speaker on. That's good. Outside.
So thanks everybody. As Elizabeth mentioned, I'm Chris Allen with Biomimicry 3.8. I'm one of the co-founders of the company. And it's a pleasure to be here to talk to you about biomimicry and geodesign. I'm going to focus on the biomimicry part of it. Mike's going to talk about geodesign and how these two are kind of coming together with some really interesting work we're doing together on some projects. First of all, who's heard of biomimicry before today? Is that a pretty common topic? A few people. Okay. How about geodesign? Is that it? Okay, great. Just briefly, my background's, I've been in sustainable development broadly for about 25 years, but coming from a business background, I'm trained as a business guy, so I've been helping Biomimicry 3.8 grow the business around this idea of translating biological intelligence to industrial design, architecture, product design, all kinds of design. I'm also trained in biomimicry. It's an interdisciplinary approach to design, so I'll talk a little bit about that as well. I give a lot of these talks kind of around the world, and a lot of times I'm talking to corporate audiences. I often ask, have you ever heard of this biomimicry? Most of them haven't in corporate environments, and so I point to this because it's starting to go from what was a fringe topic to more of a mainstream approach, or a mainstream idea, I guess. And even Forbes magazine picked it up in September of 2012, saying maybe the best idea I haven't heard too much about. There's a great article that Forbes did about this, and it's talking about innovation and the new ways that we have to find approaches to innovation. It turns out biology is a really great place to look when you're trying to innovate. Our work was is built upon a book that came out in the late 1990s and reprinted in 2007 by a woman named Janine Vinyas, who's our founder. She's a biologist. She's an evolutionary biologist by training. And the interesting story behind this is that she was working for the Forest Service in Montana doing research in forestry research, but on the side she wrote popular science books, and she had written a book on animal behavior. She wrote a lot of articles around evolutionary biology, but from a popular standpoint, a non-academic. In the early 1990s, she started starting a book exploring why is it that animals and organisms do what they do so well. They're genius at flying and making spider webs, all the things we see in nature. How is it that they evolved to do what they do so well? Early 1990s, she's going to all these conferences around the world. She's going to bat conferences and dolphin conferences. But so she said something interesting happened in the year 1994, roughly. Heretofore, when she would go to the conferences, it would be all biologists. In 1994, she was going to these conferences, and the U.S. Navy was there, 3M was there, Boeing started showing up, saying, how do we have access to the way dolphins swim? How do we begin to understand how the spiders make this silk that's so strong and so lightweight? We want to know the mechanism behind that. We want to know the chemistry. We want to know the form and process so that we can mimic that in our industrial design, which spawned the idea for this book, Biomimicry, which is studying biological forms and mimicking them in designs of all kinds. I'll just give you some examples. We'll just walk through some quickly what they look like. Is anybody familiar with the Interface Carpet Company? We're a huge sustainability success story. Arguably one of the world's most sustainable companies is a carpet company now. They're doing really amazing things. They approached us because they had a really interesting challenge with their carpet tiles. They're the originators of the carpet tile. Used to, commercial carpet manufacturers would make these gigantic rolls of carpet and roll them out. They came up with the idea of coming up with individual tiles so that you could replace a tile that was damaged or stained without having to replace the entire carpet. But they ran into some problems with matching dye lots and matching patterns over periods of time. It created a problem. So put down a bunch of carpet tiles and 3 years later you're going to take them up and replace them. You could tell that those were replaced because they had a problem. So they approached us and said, is there something we could look at in the natural world that would help us solve this problem? So we went through our biomimicry design process. A very simple thing, we took the carpet designers out into nature and we said, well, let's look at what's going on the floor in nature. It was a really aha moment for them was that they were here, before then they were designing everything with very linear and kind of standard approaches to all their layouts in the carpet. And what we see in nature is very random patterns and circular patterns and a lot of different color variations. And so they took that idea of randomness in nature and color and form and shape, and then they were able to put that into their carpet tiles, which changed their whole way of thinking about these carpet tiles, and which led to their entropy line, which is now 30% of their total global revenue in carpet tile manufacturing. It's kind of an interesting story. So it's a disruptive thinking model in this case. They typically do carpet this one way. We go out and look in the natural world and say, well, this is how nature looks like on the floor. Changes the designer's entire way of thinking about it, which resulted in this innovation. We got somebody from Japan here, I think. You're probably familiar with the Shinkansen bullet train, right? Turns out when they were trying to look at this problem, the bullet train goes so fast when it hits the tunnels in Tokyo or wherever it goes, it creates a sonic boom on the other side because they're going 200 miles an hour. They had a big design challenge. And one of the engineers, a woman on the design team for this, was also a birder. And she was very familiar with how the kingfisher, when it goes after a fish in the water, just barely pierces the water in a way that allows them to catch the fish with minimal disturbance of the water. So she started thinking about the kingfisher beak as a possible aerodynamic efficiency model for the Shinkansen bullet train. They modeled it, they ran it through physics engines, the whole thing. It turns out that the mathematics of that kingfisher beak is what shows up now in the Shinkansen bullet train. So again, this is an idea of how you take an industrial design problem and then you translate it into biology, which then leads to new thinking. Same with here's a Columbia Forest Products that had a problem with off-gassing of formaldehyde inside of their laminate products and in their plywood internal cabinetry. They were going for a really high green building rating system, so they had to figure out how we're going to get the formaldehyde out of these binding agents. They approached a researcher that they found out about that was studying how underwater mussels adhere to rocks. And they have a very strong binding agent, but it's obviously biodegradable and very high strength and that has these amazing performance features. Long story is they ended up mimicking the protein structure of an underwater mussel, put it into a soy substrate and created something called Pure Bond. Biodegradable, waterproof, super strong. Now they got their formaldehyde out of the building product and now they're cross-licensing that adhesive into all kind of other industrial uses. So here again, there's a strong industrial design challenge. How has nature already solved this? How do we go find that recipe or that structure and then mimic that in a new technology? Nissan is doing this with something called swarm intelligence. Swarm intelligence is studying how birds fly, and bees swarm, and fish school without running into each other. And it turns out that they have a little algorithm in their brain that keeps them from running into each other. Then they manage the distance between each other. Nissan took that same idea from fish and put it into a robot car that uses swarm intelligence for these cars to maneuver without ever colliding into each other. And there's an idea that
so cute.
yeah, if you're interested in this, go to YouTube and type in
Like a
Nissan.
whole bunch on this table.
Yeah, exactly. You can watch these guys, these little robot cars move through an urban environment.
Marco's next.
You and keep that table on.
So those are just a few case studies, and there's hundreds of these showing, again, how designers reach into the biological world and are finding new ways of thinking about their problem. Biomimicry is starting to take off now. Again, is going from what was a kind of a fringe idea to now a more mainstream approach, the beginning of a mainstream approach to innovation. And that's starting to show up in articles in the Harvard Business Review and Fast Company talking about this process and how designers are starting to do this. And showing up in the bookshelf too, we're starting to see university classes and university academic presses starting to create a formal discipline around different aspects of biomimicry. There's now the world's first PhD program at the University of Akron that's looking at basically polymer science and studying how adhesives and all kind of polymer properties happen in the natural world. That's funded by Sherwin-Williams, a big corporation. So they've endowed a whole PhD program in biomimetic design. But you're seeing it in computing, you're seeing it in systems modeling, you're seeing it in a whole range of applications. So our company, Biomimicry 3.8, anybody know what 3.8 might stand for? It's a little riddle. Probably not. 3.8 billion years of evolution. So life has been evolving for 3.8 billion years. The premise is that's a big design library. All these organisms, all these systems that we see now, the ones that haven't gone extinct, are like the champion adapters, we call them. And so we can study those and figure out how is it that life works best on Earth, underwater, above water, in trees, in the soil. All these organisms have all this information that we can study and apply to design challenges of all kinds. So our company, what we do is we help innovation leaders reach into this biological intelligence in a really efficient and effective way, grab that brilliance of nature design and apply it to whatever they're trying to solve. Here's some of the companies that we've worked with in the past. Interface, we talked about them. We worked with Kohler and Nike and Herman Miller, a lot of industrial design companies with R&D, significant R&D budgets that are trying to crack big problems are coming to us to help us translate the biology into some interesting ideas for them. I'm going to talk a little bit about HOK. You guys are all familiar with him because we've done a lot of work in architecture and planning. That's what I'm going to talk about after this, to kind of focus in on the built environment, and I know that's the most relevant to you guys. But before we do that, just this arguably the innovator of our era, Steve Jobs, in his autobiography recently, he says, I think the biggest innovations of the 21st century are going to be at this intersection of biology and technology. A new era is beginning. So I think biomimicry is prospecting in that area and helping companies figure out how to be at that intersection of biology and technology. And technology broadly, that could be both hardware and software and human systems and management systems. It can be a lot of different things. Just talk a little bit about our work in the built environment briefly, and then I'll turn it over to Mike to talk about how this is fitting into the geo-design framework. But most of our work to date in the architecture world has been with HOK and BNIM. I'm sure you guys are familiar with the Kansas City Architecture Group. Those are the two firms that we work with the most. We worked at urban scale, building scale, and then at what we call biome scale. I'll talk a little bit about that. We first got started with HOK in a large master planning project in India, the Lavasa, which is between Mumbai and Pune. So about a 10,000 acre large kind of new city out in the middle of nowhere, but in a very beautiful part of the Western Ghats. So we were hired to help interpret the local ecology and what the local ecology would tell designers about what's right and what's wrong to do in that particular area, based on the way that the organisms have survived and thrived in that area. Out of that came a platform that HOK developed called Fully Integrated Thinking, where we try to take a systems model looking at the ecosystem science there and then interpret that into design. Here's some example of some of the work that we did there. For example, we helped interpret what was going on with what's called the moist deciduous forest in that area, the whole, let's say, performance cycle of what that canopy layer, the litter layer, and ground layer is doing for that ecosystem. And then what are the ideas or the design principles that could be extrapolated from what's going on in the moist deciduous forest to the specific challenges on that site. And so we're able to look at things like hydraulic redistribution of water and what might be the design principle for a designer at the architect, landscape architect, engineering level that could look at that particular function that's been there for hundreds of thousands, if not millions of years, and use that as an idea or a principle for designing for that particular place. So we came up with a landscape ecological model and also what we call the ecological performance for that place. From a biomimicry standpoint, if we were to have a truly biomimetic building, that building would be performing an ecological function in that place. It would be managing air and water and soil. It would be doing things like the other structures in that environment. So what are the implications for designers in understanding the eco-structure, if you will, of that particular place? Again, here's some of the things that we were beginning to solve for and find models for, like environmental, social, and economic, from the organisms and systems that have been in that place for a really long time. And this fit model is kind of a systems model, so we can think through and try to think through as comprehensively as we can. What are the implications, again, of that intact ecosystem that's been there for millions of years, functioning at a high level? What are the design lessons that we need to pull from that for these things that we're trying to solve in those three realms? Another project called, this is called the Town Center of Kedsez, which is a special economic zone. This is an interesting kind of industrial, mixed-use industrial developments in another part of India, where we began interpreting, again, what, if we were to try to get ecological performance features out of the hardscapes and the buildings themselves, what might that look like? And so this is a rendering of some of the work that was done there with HOK. More on the building scale, another project that was really interesting that we did was for a downtown, kind of an urban regeneration project in downtown Brazil. This was a shopping center. We worked on HOK in Europe with an engineering firm. And in our process, when we go out and do this, what we try to find are what we call champion adapters, or local species that do something really, really well for that particular bioclimate. In this case, we chose the bromeliad because the bromelia is both an iconic species for that part of Brazil, but also the way it manages water and sun in that local ecosystem is really brilliant. So we introduced the bromeliad structure to the architectural engineers and the architectural designers, who then started riffing off of the idea, what if we had a building that functioned like a bromeliad, what would it do? So that led to some really interesting design, some design ideas about how, what the bromeliad does is it manages a lot of water at the very top of the plant, and it allows a little bit of that water to trickle down as needed. And so it does a lot of the water management at the very top. And so we took that idea, as you can see in some of the structure of the building, about water management for the building at the top level, and then it would allow it to trickle down through the building and then recharge a cistern down below. There could be some evaporative cooling type benefits from that as well. Plus the bromeliad for Brazilian culture is a very iconic and beautiful species, so there was an aesthetic part of it as well. Arup did the structural analysis on how the bromeliad structurally holds all that water at the very top. And what does that look like? And what are the implications for the structural members of the building? So we went through an analysis of that. We were able to extrapolate some of the structural ideas of how the bromeliad kind of membranes work, and then render that into an analysis. And here's kind of a concept of what that would look like for the downtown feature. And then lastly, before I turn it over to Mike, some of the work we've done on the biome is looking, as you know, there's a variety of biomes in the different world. These are kind of bioclimatic areas that have similar species, similar environmental factors. And so you find organisms and systems that have evolved in that place around the same kind of challenges. And so you can typically find these principles and patterns that work for a particular biome. So HOK commissioned us to do a study of the northern broadleaf temperate forest, where we began to look at what are the main patterns and principles that organisms solve for in those areas, and what are the design implications that come out of that. So we end up coming up with a library of these kind of design principles that we can point to that say, if we want to solve for environmental challenges in this area, these are some of the principles you want to look at. And here's one, for example, that we looked at, is upstream barriers to slow water. And you see that it's a ubiquitous design pattern throughout this temperate broadleaf forest. You see it in things like beaver dams, for example. And beavers are really, really important to the wetland protection of that northern, that broadleaf temperate forest. And so when we study what the beaver dam function does in that area, is it really just slows down the water and allows a certain amount of the water to recharge the aquifer, but it also creates these massive wetland areas, which is really important for biodiversity. So we start looking at a design principle that says we need to look at how do we create a series of upstream barriers to slow water. Could that translate to a leaky barrier rooftop system where we're slowing down water at the rooftop level? They're all connected in a system, which is we're getting multifunctional benefits. We're getting the ability to slow down the water, but we're also creating potential for habitat. There's a lot of things that we can do when we start to look at it from this kind of natural design principle. And with that, I'm going to turn it over to Mike, who's going to talk about what we're doing with taking these ideas and putting them in a geodesign framework.
Thanks, Chris. So we've started collaborating together in part just out of intellectual interest, and then we happened to find some clients, which was a nice thing. And
It was nice.
always nice. And one of these was a project that we're just setting up for Durban, South Africa, which is one of 100 cities that have been successful in competing for a limited amount of funding from the Rockefeller Foundation. And part of the way in which the cities compete is by honing up money and resources as well. So it's a project with a lot of local support and in a complicated region of the world. The history of Durban, I'm not sure if anybody knows much about South Africa, but the very short planner's version is that apartheid and racist thinking affected urban planning very severely in South Africa. And so a lot of the city design was done, city planning was done as concentric rings. And so there were a lot of barriers and purposeful segmentation of people. And so kind of the worst version of Euclidean zoning that you might find in the rest of the world combined with racism, you get a really, really bad city design and city layout. And they're struggling to deal with that legacy right now. So that's coming on the kind of social and economic side. Durban is a relatively poor part of South Africa, but it's a major city. And it also happens to be a world biodiversity hotspot. So you have all of these things coming together in one place. There's agreement on the need for change, but there's a lot of directions that could go. And we basically started with the biomimicry approach that Chris has just described, and tried to combine it with some work that I've been working on for the last 5 or 10 years that I started when I was at ESRI, that's known as geodesign. And so geodesign is basically the idea of making design methods that more tightly couple evaluation with design. So one of the things, this even goes back when I was in design school, one of the things I always disliked in design school is this kind of very plodding version of analysis that first you do design and then you throw it over the fence, so to speak, and you do a very single-passed analysis, and then that goes back to design. And it always felt that the value was always, you were always running out of time before you got the value from the analysis, basically. So that frustration led me to propose a set of techniques and technologies for basically building in evaluation into design tools. And so that's what I tried to do for a few years at ESRI, which is a very large software company. It's got 4,000 people. I had 5 people on my team. And I'm just now seeing some of that stuff get into their software a decade later. So we'll show you a little bit of that. It's I didn't stick around for that tall gel, but the general concept is to combine sketch planning with background evaluation. And if you do the sketch planning in one platform, and the evaluation can then be done on many other machines in parallel. So you don't want, the thing you don't want is the clunkiness of waiting for an analysis to complete while you're doing the design. So fluidity is absolutely key. And so that's a lot of what we've been pushing on. And that allows you to do things like triple bottom line analysis on the fly, which otherwise, if you use conventional software, is impossible. So the latest iteration of this from ESRI is something called GeoPlanner. That's a web-based application that lets you create, edit, and share sketch designs, basically, and to do some kind of limited subset, but of real-time evaluations. And so we combine those two concepts. How do we learn from nature, and how do we build an interactive design system? And so, with apologies for a really complicated diagram, we'll try and do the high-level view of this. So we've got a set of inputs from the site that are systems patterns. And since this is a large project, we're basically dealing with landscape ecology level patterns. And we have the ability to do standard spatial analysis on those, so we can look at a variety of those things. And the way that we've organized it is a concept you've probably heard of called ecosystem services. So the notion of ecosystem services is a fancy word for an old idea, but nature does a lot of stuff for us for free. So rather than just put that in an economic analysis as free, no, let's actually associate a cost with that so people pay a little more attention to it. And it's a hard thing to do, but there are a few really good methods, a few bad methods too, by the way. But one good method is to apply a method that's called substitutable costs. And so you basically figure out the cost of doing something stupidly with a lot of heavy engineering, and you compare that with using green infrastructure. So the classic example of that is both Boston and New York as cities had upstream water supply issues and problems, and in both cases they found a way to actually apply landscape green infrastructure principles upstream rather than to build everything with billions of dollars of concrete infrastructure. So New York managed to preserve the Catskills famously, and Boston managed to acquire a lot of the land upstream of its watershed. And both of those success stories, billions of dollars of stuff, came about by allowing the Army Corps to do their nice little estimates of how many billions of pounds of concrete they wanted to put in, and how they wanted to turn your river into a concrete channel. And let them do their stuff, and then take that budget and then apply it back into ecological design. So it's kind of turning a little jiu-jitsu move, but trying to turn classic heavy engineering on its head and say, look, we really have alternatives. So that's one way of evaluating ecosystem services, and that's one of the main techniques we use in this project. The second technique is Chris already described basically, but it's using design charrettes and design principles and precedent studies basically to really open up the discussion about what could be in a place. And then the third part of the process is a lot of scenario planning. And so again, if you have an interactive design environment, that's one of the advantages to that interaction. And so our big push is let's use that interactivity and that ability to evaluate things again and again and again to increase the number of design possibilities, not only as done by the designer, but as done with a stakeholder process. So we get a lot of design iterations into the same amount of time as we would normally do. So the first phase basically involves a lot of research, both in a design side and a kind of science side. So the biomimicry side involves looking at the way in which the systems have historically operated in the place. And then the technology starts to come in on the mapping phase. So in this particular project, we've got great base mapping because the city has already done a sustainability plan. So we have a very good veg map, we have very good biodiversity mapping. And so all we need to do for our part of it is actually assemble those and recast those in terms of the ecosystem services being provided. So for example, what's the flood control benefit of the vegetation that's there? And that allows us in the third step to basically set up ecological performance standards. And that's one of those areas I really appreciate working with Chris and Janine, because they really set a very high bar. So their bar is that this system should perform as well as nature, which is a hard but good objective to start with. And so we cycle that through all the different systems. How do we improve the biodiversity of the place while we're developing it? How do we improve the water while we're developing it? And I think that's a really useful construct to come in with. The pieces that help on the synthesis side are basically to take those ecological performance standards, and then you can do a lot of the conventional techniques I think you're probably familiar with, overlay mapping, for instance, and say, all right, where are we underperforming, where are we not, where are we doing well, where are we doing poorly? So start to focus basically by doing iterations of analysis with design. And the end goal of that synthesis is basically to get, in this particular project, to a conceptual land use diagram. So it's not a, that's the scale of the project and the client setup. So we're not looking to get to final design on this. We're trying to get to a good conceptual land use plan. And then, I mentioned this already, but basically our approach uses multiple rounds of stakeholder-based scenario planning to kind of run through both individual design ideas and then combinations or packages of design ideas. And so from this point of view, a scenario is nothing more than a package of design ideas. But one of the things that we've found in our prior work in other places is that we're able to use scenario planning for two things. One, you're probably familiar with the design version of a scenario. A second is more of a scientific uncertainty version of a scenario. And so what we're doing in this case is we're looking at climate change, for example, and population uncertainty, and saying, how does this design perform if the climate gets hotter and drier? And how does the design perform if we get more or less population increase than we think? Because those are the two big uncertainties in this particular region. So we're using scenarios to uncover both the kind of robustness of the design and robustness of the design across some areas that are known to be uncertain. It's kind of the idea. The scientific name for that is called robust decision making. So you might hear it called that. But we apply in a really specific way. We use stacks of scenarios to test our designs and say, does this hold up under high and dry climate? Does this hold up under huge population pressure? So in summary, basically we're doing three things. We're asking how we can improve the area, ecologically, economically, and socially. So again, a high bar starting goal. We're trying to develop a palette of development activities because it is a conceptual planning exercise where those kit of parts are supportive of ecological and social functions. And we're doing this using a set of new technologies that basically allow us to do much more rapid feedback and continuous computing. So we don't really have a separation between design and analysis, or if there is one, it's a hair's breadth. So we want basically every phase in this to be both design and evaluation. And if our evaluation is wrong, tell us. If our design is wrong, tell us. But we don't really want to allow those to ever be separate. And whoop, I'm off the edge of my PowerPoint. So I guess it's good because it's Friday afternoon. So that's all we had. We're pleased to take any questions.
I have a question. So like you're basically developing these models that you can use, as to design with. How do you know that you've thought of everything in your model?
You know that you haven't. And so the short answer is the stakeholder process will tell you if there are major gaps in emissions. We tend to do it in two rounds. So on the models that are more sciencey, where there's prior science, like hydrology, basically you have a hydrologist on the team and they review. So you do it first internally. But then most of the time our experience is actually the model is great. The problem is the data. And the data you only get from the people of the place. And so on a number of the other projects we've done, we've actually had stakeholder engagement exercises where we do early phase, bring up, using the models on current conditions or on historic conditions, iron out the problems right there, and get the stakeholders involved in bringing us better data. So that's usually the most important thing, is that you're missing, there's no stream gauge on this stream, so you need data about what's going on there. So we try and engage the stakeholders in improving the data. The models themselves, while they have some, clearly they always have simplifications. In our experience, the problem usually isn't the models. We use a lot of off-the-shelf stuff because it is robust. We're not making up our new hydro model for the project. But the data are usually the problem, and we just get people involved early and critiquing that even before we're designing the future. Like, are we representing current conditions well? And if you got the evaluation of the current conditions reasonably well, then that sets you on a good path anyway. You kind of build credibility. In fact, if you don't do that, you won't have any credibility with any model. So you've got to prove to people first that the model is working at all, and then you can use it for design. But I never say, jump straight to design evaluation. So you actually have to design models and prove them in a place. In our process, we do that before we ever apply them to design. And those do, by the way, have to connect directly to the issues that people care about in the place. And
so that saves you from taking something that is admittedly a simplification of what's actually going on, but you've vetted it through other consultants and experts to know that your data is reasonably good enough to base your entire model around.
Yes, and I have to say, we use a whole variety of models, and they range from the most simple to the most complicated. So I'll give you an example. I did a project in La Paz in Mexico, and it turned out, even though there's a marine biology institute there, and a major issue in the project was fish habitat, they had nothing that was able to talk about the effective development on the estuary. So 30 years of a research institute there was nothing. And so we said, well, you got the people. We're going to lock them in a room, and we're going to get an evaluation of these scenarios on a scale of 1 to 5. And it's going to be a qualitative expert judgment model, but we're going to have it. And so in a case where we cannot get, from resources, time, or whatever reason, we can't get a mechanistic, full-blown model, we'll use social process with experts to do evaluation. But we'll set it up in a way that basically we've got some credibility of that evaluation, that's still was an objective model being applied to multiple designs in the same way.
So how do you begin the process of understanding the model? Do you begin with the data that you can get sort of easy access to, and then try to sit down and put together sort of a flow chart of how these things are coming together?
We usually begin the stakeholder process with the issues. And so we force people to be helping us to do the scoping because there are an infinite number of models you could apply, right? And so we're really upfront. Hey, we have the resources to do 12 models. We're not doing 15, we're not doing 300. So which are the 12 most important becomes the subject of the initial stakeholder consultation, sometimes the client consultation in advance. Usually actually both. So usually with a client we say, look, you can't ignore hydrology, you got a floodplain here. So we come in with a little bit of the study we do even in a proposal phase to say, look, no, we got to do at least these things. But then from there on, it's issue driven. And certainly in terms of the amount of attention we pay to any of the models, it definitely comes from the level of importance relative to the study. So if flooding is the issue, we're going to spend most of our time and resources on flooding and not on drought, and vice versa in a different place. But it does come from the issues, not from the data. And the reason is it's very easy to get seduced by the data. You got great data on flooding. Oh, that must be the issue. No. So, we will get the data, even if crude, to get at the issue, but we are not basing it on what's the best available data. So if flooding is the issue and the only data we have is the stakeholders walking around and giving us stuff, we'll use that. But we really want it driven by their ranking of the priority issues. And we do the same trick on scenarios, by the way. We're not doing 500 scenarios, we're doing 6. You guys tell us which are the 6. And we'll have a stakeholder process to figure out the most important 6, and there'll be a vigorous debate. But basically, I've always found it good policy to kind of engage the stakeholders in the scoping, because then they're much more forgiving. They understand the resources that are available, and they're happy that they can do 6 scenarios. I'm sure they always want a 7th, but they also always want another design round. And so you're just upfront about that in the process, and you get either the client or the stakeholders or both engaged on scoping. And when things go out of control, you hold another meeting and you rescope it, because we just ran out of resources to do the fancy hydro model, or the hydrologist said it's going to take 6 more years to get that, and we need an answer in 6 months. So
it's interesting. I feel like that's been one of the biggest evolutions in the design profession over the last, like, I don't know, 20 years or so is, looking at, like, from a McCartney standpoint of like sustainability, you always assume the experts kind of know what's going on and sort of the top-down administration of these things is the right way. But it seems like more and more we're realizing there's more information in the community and kind of crowdsourcing these things that lead to an infinitely better design product that everyone's vested in.
It's usually honestly a combination of both. I mean, you still need the hydrologist, you still need the expertise, but the toughest thing is when you get boxed in by the client up front. And in all honesty, if you don't have resources to do hydrology in a project, then you're in an uncomfortable position. So we try to get latitude up front, and I think biomimicry is kind of a purposefully broad initial construct, right? So we're carving out a lot of space for design there. But clearly, like everybody else, you get pruned back. But I do think that's very, it's no longer just expert based. But on the other hand, if you have a stakeholder group telling you that flooding is their major issue, they want the hydrologist there.
Michael, when you worked, are you coming in with a team, or I'm not quite clear on how you go about the project?
That's a good question.
Do you come in, are you the prime consultant, and then you bring your hydrologist along with you, or how do you get design involved in that?
Depends a lot on the scope of the project, I guess I should say. So I've worked both as prime and as a sub. And biomimicry also does both. So we have a fairly fluid team on both sides, and so I do have a consulting hydrologist, and I can bring them in, or I can work with the existing hydrologist that's in a site, and if there's a good hydrologist there already, then
do you work at a lot of different scales? Because I can definitely see how this applies to the land planning project. But so what types of scales do you work on? Very small sites also, as well as larger sites?
Chris does. I do less. So I guess I would say I tend to work at neighborhoods and broader. So I've never done a garden design outside of school. I wouldn't be competent to do so. The largest stuff I'm doing keeps expanding, but largest stuff I'd done recently was the whole state of Florida, 800 miles of beach, and all the landscape thereof, and 16 endangered species. And I just got something to do some work with NOAA, and it's going to be even bigger than that. Or the Great Basin, which is another thing that blows my head to think about the scale. But basically, the short answer is that it depends on time and resources. Again, if the client is flexible, we almost always try to do a design partnership. And if we don't have resources to do it for the whole project, we do it for drop-downs. We say, look, there's 3 key areas in this region, and we need a design firm to help us think about those 3 areas. So
you provide kind of a basis of analysis and scenario planning, and then you bring a designer in to actually take those pieces. Because one thing that's sort of missing here is sort of the alchemy of designing. You guys do a great job of quantifying and abstracting and understanding the things that we sort of treat intuitively. I think we sort of intuitively understand natural systems, but we don't ever, for instance, say, well, if this water didn't naturally cleanse itself, or if beaver dams didn't do their job, then there would be a huge infrastructural cost to that. We never quantify it, but we sort of intuitively work with nature, because that's how we are trained by Carl Steinmetz. But you guys take that much further to show actual value. I think it's really interesting.
Not to say, I mean, that a lot of our work comes from legalistic constructs, which maybe we're setting the table for design, we hope. But I get called in a lot on endangered species and climate change planning. And so it's endangered species driving something, but right now that's going to drive a lot of future development in the U.S. or lack thereof. So a lot of these things come out vulnerability assessments or kind of broad scale, gee, we've got this social problem, we got to deal with the sea level rise. And you know, we do a good job at the broader scale piece and in the early design piece, and then we partner, as I think has been obvious in even the few projects we showed you, we will partner with design firms when we want to go deeper in any particular aspect, and when we want to drop down in scale and build examples of how something might look and feel, because that's not what we do, and we can't tell you how it's going to look and feel. So that's kind of how I see it coming together.
Great. Well, does anybody else have any questions? I think we're all kind of reached the ends of our Fridays here.
Thank you so much for
Really
sharing
great.
your Friday afternoon with us.
Thank you so much.